In this video, we're going to talk about solving exponential equations using logarithms when common bases are not possible or impossible. But first, we're going to review a little bit when we can get common bases. So I have 5 to the n plus 10 equals 25 is 5 squared. So I have n plus 10 equals 2. So n is then negative 8. And then I have 9, which can be written as 3 squared to the a plus 2. And then 27 is 3 cubed to the 4a minus 2. So then I have 2a plus 4 equals 12a minus 6. So when I solve, a is 1. So that's just to review from what we did earlier in this unit. So what if a common base is impossible? You're going to isolate your exponential expression. You're going to take the logarithm on both sides. You may have to use your power rule to expand the logarithm. And then we're going to solve and then check for extraneous solutions. So make sure you are rounding to 4 decimal places just for sake of life. So I cannot, this example, number 3 here, I cannot write 61 as a power of 2, but I can rewrite it using my log to exponential, my exponential to log thing. So I have log base 2 of 61 equals x. And I also don't know what the log of base 2 of 61 is. So I'm going to do change of base formula. So I have log of 61 over log of 2 equals x. And that gives me 5.9307. So that is what x equals. So if I wanted to do 4 here, I'm going to have log base 8 of 92 equals m minus 7. Once again, I don't know what that is, so I'm going to use my change of base formula. So log base 92, log base 10 of 92, and then log base 10 of 8 equals m minus 7. So m minus 7 equals 2.1745, and then add 7. So m equals 9.1745. So let's do number 6. So we want to isolate this exponential first. So we're going to add 5. So I get 4 to the 3w equals 8. I'm going to have log base 4 of 8 equals 3w. So then I'm going to use my change of base formula. Log base 10 of 8 and log of 4 equals 3w. So 3w equals 1.5. And divide by 3, you get 0.5. So w equals 1/2 or 0.5. So let's stick with the odds. So we are going to simplify, we're going to isolate our exponential here. So we're going to subtract 7, so I get negative 4 to the x plus 1 equals 11. And then I'm going to divide by negative 1. So I have 4 to the x plus 1 equals negative 11. So log base 4 of negative 11 equals x plus 1. Well, you can stop here because we cannot have a negative 11 as a log, so there's no solution because logs cannot be negative. And then we have this one. So let's subtract 15. So I get 344 equals 4 times 3 to the n, and divide by 4. 3 to the n equals 86. That means log base 3 of 86 equals n. So log of 86 divided by log of 3, not base 3, just 3, equals n. Log of 86 divided by log of 3, n is equal to 4.0545. 11, let's subtract 1, so I get 180. 5 times 9 to the v minus 1, and then 180 divided by 5 is 36. 9 to the v minus 1, so then I have log of 9 of 36 equals v minus 1. So v minus 1 equals log of 36 over log of 9. So v minus 1 minus 1 equals 1.6309. And then add 1. So v equals 2.6309. Nope, go away. And 13, last but not least. Let's add 2, so you get 84. Equals 6 times 16 to the 7y plus 2. 84 divided by 6 is 14. 7y plus 2 equals 14, so log base 16 of 14 equals 7y plus 2. So then we're going to use our change of base formula. Log of 14 divided by log of 16 equals 7y plus 2. So log of 14 divided by log of 16. So 7y plus 2 equals 0.9518. And then solve for y. So subtract 2 and divide by 7. So you get negative 0.1. Wow, can't read a calculator. 1497. So that's how you solve exponential equations when you can't find the same base.